Okay, welcome to Unit 1, Lesson 1 in Algebra 2. This topic is applying properties of real numbers. This topic is mostly a review of Algebra 1, but I think you're going to have some things that you don't think you've learned before. So our objective today is to study the properties of real numbers, and that objective will always be at the top of the file or at the top of the video at the beginning, and that'll just kind of give you guys an idea of what we're going to be learning that particular lesson. So I usually start these lessons with a key concept, and a lot of times it's going to be a diagram or a formula or some kind of reference that you guys can use to come back to do the practice or to answer some questions that I might have that are part of the lesson. So this key concept concerns the subsets of the real numbers. So the real numbers consist of the rational numbers, irrational numbers. Two subsets of the rational numbers are the whole numbers, which are just positive whole numbers, including 0, and the integers. So those are positive and negative whole numbers. So what you guys have dealt with throughout basically your whole math careers is real numbers. And we dealt with real numbers all through geometry, and those real numbers are split up. Rational numbers can be written as a fraction of two integers. Those create decimals that either terminate, like 0.75, or repeat, like negative 0.3 into infinity, okay? So those are the biggest set of those rational numbers. Those are fractions, but below that includes the integers, those positive and negative whole numbers. So those are contained in the rational numbers. Inside of the integers, we have the whole numbers, and those are just, like I said, the positive integers, positive whole numbers, including 0. 0 is considered a whole number. As far as irrational numbers, those are numbers that can't be written as a ratio or a fraction of two integers. So that means those are decimals that don't repeat and don't end. So basically any square root that isn't a perfect square is irrational. We're going to encounter some other numbers that are irrational. You guys have worked with pi before. Pi is irrational. Pi does not repeat. Pi does not terminate. Okay? And we're going to talk about some things that concern those rational numbers and how we deal with them, because we need to know how rational numbers operate in order to use them to do more complex math. So I've got some just quick notes down here of rational and irrational numbers. Okay? So one thing about rational versus irrational numbers, we can graph those on a number line. So with this particular number line, we're looking at negative 13 over 5 and square root of 6. And comparing those numbers isn't really easy just by looking at them. So I would want to get those two numbers in the same form. The way I would do that, I'm going to make them both decimals. I'm going to write negative 13 over 5. If I put that in my calculator, that's going to give me negative 6.5. Okay? Square root of 6, that's going to be roughly 2.45. So I think that's much easier to compare. So on my number line, I'm just going to number it starting with negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. And I will try to make my handwriting better throughout these videos. This is the first one, so I'm kind of rusty. Okay? So if I'm going to graph negative 13.5, I'm just going to look between negative 7 and negative 6, and that's where negative 13 over 5 is going to wind up, okay? Negative 13 over 5. For square root of 6, 2.45, that's going to be between 2 and 3. So I'm just going to put a little dot, a point there, and that's going to be where I place, can't write, square root of 6, all right? So pretty straightforward to get those real numbers graphed on a number line, all right? So most of it's just a matter of being able to put it into a calculator to compare them, all right? And I know you guys probably covered this in Algebra 1 This is a good review, good way to get you started on this, okay? So towards the bottom of this first page of notes, I'm going to introduce you guys to another key concept, and those are the properties of real numbers. And these are things that are true for all real numbers, okay? All real numbers behave this same way. And these properties only concern addition and multiplication. And we're going to talk about how we can rewrite things with addition and multiplication and with subtraction and division. So any property that concerns closure, all that means is if I have two real numbers and I add them together, the result is a real number, okay? Under multiplication, for closure, a real number times another real number results in a real number. Okay, so that's closure. This commutative property. When you think of commute, you think of move, okay? So the commutative property says order does not matter in addition. These are the same sum. A plus B is the same as B plus A. So if I move around the order of the numbers in addition, it doesn't change the result. It doesn't change the sum. The commutative property of multiplication, order doesn't matter in multiplication. I can rearrange the order of the numbers in that multiplication, and the product, that result, is still the same. So commutative property, that changes the order of the numbers, okay? The numbers in your addition, the numbers in your multiplication. The associative property, okay? Think of grouping. Associate means to group. So these parentheses around A plus B, those are grouping symbols. The associative property moves around the grouping symbols. I did not change the order of these digits in A plus B plus C. So all I did was I put the parentheses around A plus B in the first sum. In the second sum, I just put the parentheses around B plus C. And it works the same for multiplication. In the first product, I put the parentheses around A times B. In the second product, I put the parentheses around B times C. So associative property moves around those grouping symbols, those parentheses, okay? The identity properties of addition and multiplication. This is what can I add to a number to keep it the same value. The identity property for addition is if I add 0 to a number, that doesn't change the value of that number. And this just changes that order. 0 plus A is the same as A plus 0. It's still A. So the identity property of multiplication, what can I multiply by A to keep it the same? I can multiply A by 1. And that keeps A the same value. So identity is what can I add or what can I multiply to keep the value the same. Inverse property. For addition, the inverse, the additive inverse of a number is what added to that number gives us 0. A plus negative A gives me 0. For multiplication, the inverse property, what can I multiply by A to give me 1? I can multiply A by its, and this is a term back from geometry, hopefully you remember it. This is the, hopefully you can read this. Oh my God. Reciprocal. Sorry about that. The reciprocal, okay? The reciprocal of A gives us 1. If I multiply A by its reciprocal, I get 1, okay? And then the distributive property at the end. That's kind of one on its own, all right? It involves multiplication and addition or subtraction. But just distributive property means I can distribute A through, and I can combine like terms at the end. So we've done distributive property before. I know that. So that one's kind of tacked on at the end. So I've just got one more example before you guys are going to do a little bit of guided practice for me, okay? So identifying the property that these statements illustrate. The property for the statement for A in example 2, 6 times 3 in parentheses times 2, and then this is 6 times 3 times 2 in parentheses. So if I look at this, if I look at the order of the numbers in this multiplication, it doesn't change. 6, 3, 2. 6, 3, 2. So it's not the commutative property. It has to be the associative property because I changed where those grouping symbols were. So I would say, and you guys can kind of abbreviate with these, I'm okay with that, but this is the associative property of multiplication. The associative property of multiplication. So it's determining what property is being used when, right? Second one, part B, 21 plus negative 21 gives me 0. And I could reference our properties at the top, but these are additive inverses of each other. So this is the inverse property of addition. So the inverse property of addition. What plus 21 gives me 0? Negative 21. So I would like you guys to take a minute, do this guided practice. Try these problems on your own and see where you're at, okay? And then we're going to continue on with the next examples in another video, but I really want you guys to be able to see how I do some problems and then try and recreate that on your own, okay? So at this point, this would be a good time to maybe just check in with me or check the answer key of the notes on Classroom just to make sure that you're doing it right, okay? Once you've got that, you can move on to the next step in your lesson, all right? I hope this video explained things well. They will get better as the year goes on. This is the first one. It was a little longer than I wanted it to be, but if you guys hang in there, I will keep trying to revise these and make these better as the year goes on.